Good afternoon, ladies and gentlemen. I am going to talk about outer membrane vesicle of bacteria, of gram-negative bacteria that could be act as a strategy of bacteria in many steps of life cycle, or may be used to serve as a biological tool against pathogenesis of microorganisms and to prevent of bacterial infection in health and medical system research and vaccine research and development. Okay, at first, what are outer membrane vesicles? What are OMV in abbreviation? Outer membrane vesicles are a small spherical structure about 20 to 250 nanometer in diameter that produced by growing cell, not products of cell lysis or cell death. In a variety of environment, including liquid culture, solid culture, and in biofilm as well as during period of bacterial stresses. Outer membrane vesicle consists of two membranes called the inner and outer membrane phospholipid. For example, different outer membranes, proteins, peptidoglycan layer, LPS, and the periplasm. OMV consists of the protein and lipid of the outer membrane and periplasm and do not contain intramembrane and cytoplasmic component. As you know, outer membrane secretion is the secretion of bacterial lipid, membrane protein, different membrane protein, and other insoluble compound. For example, vesicle produced by E. coli or Pseudomonas account for about 1% of outer membrane material in the culture. In contrast, meningococci produce abundant number of vesicles constituting about 8 to 12% of protein and endotoxin in log phase. Both pathogenic and non-pathogenic of gram-negative bacteria secreted vesicle, but in general, pathogenic bacteria produce more vesicles than their non-pathogenic counterparts. For example, enterotoxigenic E. coli produce about over 10-fold more vesicle than non-pathogenic E. coli. Similar pattern in vesicle production occur for locotoxic and non-locotoxic Actinobacillus, that the pathogenic strain produce over 25-fold more vesicle. As you see in this slide, SDS page analysis of outer membrane vesicle that contain different outer membrane proteins. For example, in Neisseria meningitidis serogroup A, pure A, class A outer membrane protein, pure B, B2, B3, class 2 and class 3 outer membrane protein, and another outer membrane protein in vesicle, in SDS page analysis. And in this slide, you see that outer membrane vesicle, intactness of outer membrane vesicle in electron micrograph, that the range of 100 to 150 nanometer in diameter. Okay, functional role of outer membrane vesicle. Outer membrane vesicle have multifunctional activity, have multifunctional role in bacteria. For example, outer membrane vesicle could be act as a secretion and delivery system. Secretion and delivery system, for example, for toxin and non-toxin virulence factor. Outer membrane vesicle enable bacterial survival by defense and resistance. For example, outer membrane vesicle production can quickly remove a surface attacking agent from bacteria. For example, production of outer membrane vesicle increase the survival of bacteria treated with lytic phage, or also absorb other molecules such as complement and antibiotic. Another roles of outer membrane vesicles is nutrient acquisition, biofilm production, and in conclusion, bacterial pathogenesis. Secreted outer membrane vesicle can play a role in pathogenesis, quorum sensing, nutrient acquisition, and host-parasite interaction. About immunomodulatory activity, I want to talk the composition of outer membrane vesicle, make them significant activator of host innate and acquired immunoresponse pathway. In addition to the potent immunomodulator molecule LPS, vesicle contain different outer membrane protein and other important innate immune activating ligand. Together, vesicle component could be act synergetically to modulate the host response in ways that can either stimulate the clearance of pathogen, friend for me, enhance the virulence of infection, foe for me, or both. In addition, the immunogenic properties of outer membranes vesicles lead to protective mucosal and systemic bactericidal antibody response that have been exploited for vaccine purpose. For example, outer membrane vesicle from Salmonella enterica is a stimulator of pro-inflammatory cytokine secretion and immunocell activation. Or Salmonella outer membrane vesicle activate macrophage and dendritic cell to increase level of surface MHC class II expression, as well as the production of pro-inflammatory mediator such as TNF-alpha and IL-12, and also activated CD4 plus T cell. As a pro-inflammatory response, about outer membrane vesicle of H. pylori elicit an IL-8 response, as to Pseudomonas aeruginosa vesicle do. Detergent-generated vesicle from Neisseria meningitidis have been shown to trigger the production of numerous pro-inflammatory cytokines from polymorphonuclear, including TNF-alpha. Okay. Outer membrane vesicle containing the native configuration of different classes of outer membrane protein and other antigens such as LPS. Native as well as engineered vesicle to correctly fold and stabilize proteins and optimize antigen presenting cell. This application could be used in new generation vaccine research and new adjuvant with microbial origin development. I'm going to explain the potential properties of outer membrane vesicle and delivered as a vaccine antigen used as a hapten carrier, and you see its capacity to strongly induce immune response when co-administrated as a general adjuvant. It is well known that meningococcal outer membrane vesicle makes a good and safe vaccine, as demonstrated in several clinical trials, and in addition, it has also been shown that immunization of mice with Neisseria lactamica outer membrane vesicle induces a cross-reactive antibody with meningococci and primes for an enhanced response to meningococci immunization. Outer membrane vesicle isolated from other commensal Neisseria can be a delivery vehicle for heterologous vaccine antigen. Also, outer membrane vesicle of Vibrio, chlora, Bordetella, pertusis, Francisella tularensis, and Brucella are being evaluated as vaccine candidate. All preparation of Neisseria vesicle vaccine stimulate protective mucosal and systemic bactericidal antibody response, with the antibody response being generated predominantly to the outer membrane purines. Pure A is the class A outer membrane protein, and pure B is the class 2 outer membrane protein. Research is currently focused on the engineered bacterial strain to produce outer membrane vesicle containing multiple pure A protein derived from different strains in the hope of developing global meningococci serogroup B vaccine. Outer membrane vesicle adjuvant property. OMV could be act as a adjuvant, universal adjuvant. The most of classic and introduced adjuvant causes local and systemic hypersensitivity reaction and are not licensed for human use According to this drawback of currently applied adjuvant, outer membrane vesicle would be a safe adjuvant with high potency to induce a typical secondary response, since the OMV used in our vaccine formulation has been used previously in human trial and was found to be safe. Several reports have been described that polysaccharide antigen stimulate immunologic memory when combined to outer membrane vesicle, because has been shown to have T helper mitogenic activity. Thus, the availability of such outer membrane vesicle component with adjuvant property will be of great importance for the development of improved and combined vaccine for a wide variety of diseases. In addition, the adjuvant property of outer membrane vesicles derived particles have been demonstrated for potential cancer vaccine. Outer membrane vesicle could be act as a carrier in conjugated vaccine. With the adjuvant property of meningococcal outer membrane vesicle, were expected the potency of OMV as a carrier conjugated to hapten is now proven. It has been documented that polysaccharide from bacterial capsular polysaccharide, or LPS with protein conjugate are usually immunogen in mice and rabbit as well as in human. Many studies have shown that these conjugate vaccines elicit humoral and cellular to many pathogens in human, including Neisseria meningitidis, Vibrio chlora, Haemophilus influenza, and Shigella sonei, as well as Brucella. Covalent linkage of the polysaccharide to carrier, for example, protein, produce glycoconjugate, which are T-dependent antigen and prime for boosting either with glycoconjugate or the LPS. On the other hand, polysaccharide or LPS protein conjugate have been proven to be effective in several cases, and well-defined glycoconjugate vaccine have also been explored with a view to elicit a discriminating immunoresponse. Okay, outer membrane vesicle, another function, another application. As a nano-sized drug delivery, we could mimic the design and synthetically produce outer membrane vesicle, or even better, use appropriately engineered bacteria themselves to produce large quantity of secreted outer membrane vesicle with a content and specificity of choice. Okay. What is about the future direction? About our R&D research, the utilization of outer membrane vesicle as a complex of antigen in their native context with a natural adjuvant has already proven successful for human vaccine. The presence of LPS in outer membrane-based vaccine has emphasized the ability of LPS to act as a natural adjuvant to the immune system. Future effort will likely result in outer membrane vesicle vaccine engineered to reduce endotoxicity and include multi-species specific antibody. Okay, I want to explain a magic research that recently published. Bioengineered bacterial outer membrane vesicle as a cell-specific drug delivery vehicle for cancer therapy. This work proposed that bioengineered outer membrane vesicle have great potential as cell-specific drug delivery vehicle for treating various cancer. The well example of communicable vaccine research linked to non-communicable vaccine research. This study have three steps. The first researcher described bioengineered bacterial outer membrane vesicle with low immunogenicity that can target and kill cancer cells in cell-specific manner by delivering small interfering RNA, siRNA targeting KSP, and then a mutant E. coli strain K12 that exhibit reduced endotoxicity toward human cell was engineered to generate outer membrane vesicle displaying a human epidermal growth factor 2, HER2 specific antibody in membrane as a target ligand, systemic injection of siRNA packaging outer membrane vesicle caused the targeted gene silencing and induced a highly significant tumor growth regression in animal model. Basic research are involved with the identification or determination of the role of outer membrane vesicle in pathogenesis, quorum sensing, immunomodulatory, and in conclusion, host bacterial interaction. This effort will help to understand the capability of outer membrane vesicle in benefit application of vaccine research and development. Thus, the availability of such outer membrane vesicle component with adjuvant properties will be of great importance for the development of improved and combined vaccine for a wide variety of disease. Thank you for your attention.